Hi students, welcome to today's class. So today I am going to explain how to solve the problems related to variable and separable method. But in examination they will ask simply the question solve 3 e power x tan y into dx plus 1 minus e power x into secant square y dy is equal to 0. They won't mention using a variable and separable method or homogeneous method or linear differential equation form like that. They won't mention anything. But the thing is, you have to identify that can we make into a variable and a separable method. So before starting this method, I will give us brief introduction about this variable and separable method. So then we have to get a form that f of x into dx is equal to f of y times dy. That means you have to get a function in the variables x multiplied by dx and you have to get a function in the variable y multiplied by dy. Afterwards, if you integrate on both sides, you will get a solution for the given equation. Okay, now then how to do this problem? So here the variables are x and y, very clear. So first thing what I will do now, so first I will take this second term to right hand side. First to take the second term to right hand side. Okay, so then what happens? 3 e power x into tan y into dx is equal to minus 1 minus e power x secant square y dy. Okay, now the first thing what I did is, if there are two terms are there, put dx. So here dx one side and dy one side. First thing you have to do, for e is equal to one side dx and another side dy, then that is over. So dx and dy over. Now we have to keep f of x here. We have to get f of x, that means a function in x. So already it is 3 e power x. Now let us bring this 1 minus e power x to left hand side and tan y to right hand side. We can do that, nothing wrong in it. So first thing what we did, so dx we put in the left hand side and dy in the right hand side. That means this condition is satisfied. Now we have to create a function f of x here and f of y right side. Then how to do this? Already e power x is there. So put it e power x is. So we don't want tan y here. Here we don't want 1 minus e power x. Why? Because it is a dy. That's why you can adjust the terms like that. So take tan y to right hand side, 1 minus e power x to left hand side. So like that I can do. So 3 e power x upon 1 minus e power x dx is equal to minus secant square y upon tan y dy. So this is called variable and separable method. Variable and separable method we can call it as. Okay, now everything is over. So variable and separable method. Then what we have to do? We have to integrate on both sides. So let us integrate on both sides. So very clear. So we know the one very important formula in integration, f dash of x upon f of x dx is equal to ln of f of x plus c. Okay, now right. So here also 1 minus e power x derivative is how much? Minus e power x. That's why, so it is minus need not there, keep minus here. Okay, now then what happens? So here we have a formula here. So 1 minus e power derivative is minus e power x. So tan y derivative is secant square y. So this is equal to minus, you can cancel minus here. So that is equal to 3 of ln of 1 minus e power x. This is equal to ln of tan y. So now here a very important point that you have to keep it in mind is, you have to take the constant of integration. Generally we will take the constant of integration as plus c. But see the functions here, it is a logarithmic function, it is also a logarithmic function. That's why to make this function, this solution into in a simplest form, so better you take the constant of integration as ln c. Understand this, ln c. Okay, so then we will have this is a ln of 1 minus e power x whole cube. This is ln of c tan y. okay, c tan y. So we can remove both sides ln. So this is equal to 1 minus ex whole cube is equal to c tan y. So this is your final answer. Understand this? So from this problem what you have to understand is, whenever you got the functions in ln forms, that means logarithmic forms, then here also you take the logarithmic. Constant of integration is also as logarithmics. Okay, now I hope that you understand this solution. Let us go for next problem. Welcome to this second problem. So we have to solve xy square dy by dx is equal to 1 minus x square plus y square minus x square into y square. So we have to find out, this is a differential equation. We have to find out the solution for this differential equation. Okay, now that means we have to find out a equation of the family of curves, equation of the formula of curves, whose solution is this, then how to do this. So in the examination, as I already told you, they won't mention any for using this method, they won't give any hint. Just by observing this, we have to solve it. Then how to proceed is, first thing, see the right hand side part, 1 minus x square plus y square minus x square y square. Can we factorize that? As easily it can be factorized. So here first term as it is, you write down 1 minus x square plus y square is equal to 1 minus x square. This is 1 minus x square into 1 plus y square. Therefore, your xy square dy by dx is equal to xy square dy by dx is equal to 1 minus x square into 1 plus y square. So then easily you can separate into variables and separable method. So this is a y square, bring this side 1 plus y square dy. This is 1 minus x square by x, take this as dx. Okay. So be remember that there is no rule, such rule that this left hand side dx should be there, dy should be there, right hand side only dy should be there. There is no such rule. So you can put anything. The thing is, if it is dy, it should be here, it should be a function of y. If it is a dx, it should be a function of x. Then how to differentiate this? First of all, before integrating this, so let us once again simplify this. Y square by 1 plus y square, it is an improper fraction. It is an improper fraction. How to make it into a proper fraction means, can I write down it as a 1 minus 1 by 1 plus y square just by observation. So take LCM, 1 plus y square minus 1 plus 1 minus 1 will get cancelled, you will get y square. It is a proper fraction. Okay, now, so this also is separate, 1 by upon x minus x. So this is equal to dx. Then now it can be easily integrable. Okay, now, so take integration on both sides. For 1 with respect to y, what is the integral? So this is x, this is equal to tan inverse of y. This is equal to log x means ln x minus x square by 2. Okay, now what is the constant of integration we have to take? Is it we have to take a lnc? No. Why? Because so it is a x and this is a trigonometric function, this is algebraic function, this is a logarithmic function. Again it is a algebraic function. Therefore, so no need to take any lns. So simply you can take the c. So for the family of curves, that is x minus tan inverse of y is equal to ln x minus x square by 2 plus c. This is the solution. Understand this? So this is the family of curves. For this is the general solution. Okay, now, right. So I hope that you understand this solution. Let us go for next problem. Dear students, welcome to this concept. This is a reducible to variable and separable method. So there are some certain differential equations are there. Now so far we have seen two types of differential equations. They are easily the variables and separables. The variables will be separated very easily. But there are certain problems are there. So they are of the form. So they are of the form dy by dx is equal to, so f of ax plus by plus c form. Okay, now. So this type of equations will be there. So that is a function of linear expression, a function of a linear expression, so it will be there. Then by taking a proper substitution, we can reduce it into variable and separable method. We can reduce it easily. Okay. So let us see such a type of problems. Okay. Welcome to this problem. Solve dy by dx is equal to 2x plus 3y minus 1 by 4x plus 6y minus 5. Okay. Now, how to solve this type of equations? Okay. Now, if you observe, do you observe anything this expression? Anything your expression? So, here observe here, this is 2x plus 3y, this is 4x plus 6y. That is, this is 2 times 2x plus 3y. Right it or wrong? Right it or wrong? That means you can write this expression as dy by dx is equal to 2x plus 3y minus 1 by 2 times 2x plus 3y minus 5. First thing you have to observe is there any same expressions, like expressions, can we get it or not? Definitely, surely you will get, right? Automatically, then we will go for substitution method. So, what is the substitute method? Put 2x plus 3y is equal to t. Now, so everything we are going to convert into in the variables of y and t. Now, differentiating with respect to x on both sides. So, that is a 2 plus 3 into dy by dx is equal to dt by dx. This implies dy by dx is equal to 1 by 3 times dt by dx minus 2. Okay, now you change the problem. So, in place of dy by dx, I will write it as 1 by 3 times dt by dx minus 2 is equal to. So, 2x plus 3y value is how much? T. T minus 1 by 2 times 2x plus 3y value 2t. 2t minus 5. Okay, so now take the 3 to that side. So, this will become dt by dx minus 2 is equal to 3t minus 3 by 2t minus 5. Okay, now your dt by dx. So, dt by dx is equal to, so dt by dx is equal to 3t minus 3 upon 2t minus 5 plus 2. Okay, so next step is dt by dx is equal to, this is 4t plus 3t 7t minus 10 minus 3 minus 13 by 2t minus 5. Understand this? So, this can be written as 2t minus 5 by 7t minus 13 dt is equal to 1 dx. So, this is so here dt. So, this is in the form of variable and separable method. Understand? So, let us any more mistake here, 2t minus 5. So, that is 2t minus 5 by 70 minus 30. Now, what you have to do before integration? Observe here t, here denominator is also t, both powers are same, therefore, it is an improper fraction. So, for improper fraction, so finding the integration is very difficult. So, that is why make it into proper fraction. Okay. How to do is, so just simply divide 2t minus 5 with 70 minus 30, ordinary division. So, with what number you have to multiply with 70, so that you will get 2t. So, generally, so this is equal to 2t by 7, not simply 2 by 7. So, if you multiply 70 into 2 by 7 is equal to how much? 7 will get cancelled 2t. Okay. So, this is equal to 2t minus 13 into 2 by 7. So, 13 into 2 by 7 how much? 26 by 7. Now, subtraction minus plus, it will get cancelled. Okay, so this value will become how much? This is 26 by 7 minus 5. So, 7 5s are 35, that is equal to minus 9 by 7. Okay, 7 5s are 26 by 7 minus 5, 7 5s are 36. So, 26 plus 9 35, so minus 9. Therefore, so your integration will be there. So, this is equal to 2 by 7, this total fraction 2 by 7 plus minus 9 by 7 by 70 minus 3t dt is equal to 1 dx. Understand this? So, very, very nice. So, now separating this. So, this is equal to this is a 2 by 7. So, 2 by 7 t, that is a t minus 9 by 7 into 70 minus 13. So, what is the ln of this is equal to ln of modulus of 17 minus 13, but here numerator it should be 7 is there, not there. That is why denominator we will put by 7. So, this is equal to x plus c. Okay, that is all. Almost the problem is over. So, do simplify that and put in place of t, to do not forget to keep the substitution, t is equal to 2x plus 3y. There you substitute 2x plus 3y, you will get the answer. On the whole, from this total problem, what the point that we have to take it in mind is, so by seeing the problem, is there any chance of substitution is the possible? Yes, it is possible. Then here I have taken 2 common outside, in place of 2x plus 3y, we have substituted t and automatically we got a variable separable method and we got the answer. But at the end, do not forget to replace 2x plus 3y in place of t, that will be your final answer. Okay. I hope that you understand this solution. Next we are going to see a very, very important problem which was given in 2020 JEE Mains examination. Okay. Welcome to this problem. So, it was given in 2020 JEE Mains examination, very, very easy problem. So, I hope that everybody will do this problem. Almost those who are seriously preparing for examinations, they will do this problem. So, the options are also available. So, I am just concentrating on the solution. Okay, right. Then how to do this problem? See here, the question is dy by dx minus y plus 3x by log of y plus 3x to the base c plus 3 is equal to 0. Then how to do this problem? See here the solution of the differential equation. Anything you are observing, anything common terms are there, any common terms? Definitely. So, just by any difficulty we can say that here y plus 3x is there. So, in the denominator is also y plus 3x is of course log of y plus 3x. So, immediately we should get an idea that put y plus 3x is equal to dt, substitution method, that is all. So, this implies dy by dx plus 3 is equal to dt by dx, that is differentiating with respect to x on both sides. So, this implies dy by dx is equal to dt by dx minus 3. Okay. Now, rewrite the given equation using the variable t. So, here dy by dx is equal to how much? Dt by dx minus 3 minus y plus 3x is equal to how much? T by log of t to the base e plus 3 is equal to 0. Okay, now, right. So, here minus 3 plus 3 you can get cancel here. So, this is equal to dt by dx is equal to, so this implies log t to the base t, take that side. So, sorry, this is equal to t by log t to the base e minus that side. Okay, now let us separate it into variables and separable method. So, take t by log t to the base e to the left hand side. This will become log t to the base e by t dt is equal to 1 dx. So, this is a variable and a separable method. Separable, it was separated. Now, the next thing is what have to do? Integrating on both sides. Okay. So, here log t base c divided by t is there. What is the derivative of log t? Log x, 1 by x is there. What is the derivative of log x? 1 by x is there. That is why this is nothing but log square t to the base c by 2 is equal to x plus c. Constant of integration is c. So, in place of t again reduce so this is equal to log square, this is 1 by 2 times, this is 1 plus 3x is equal to x plus c. This is the family of curves. This is the family of curves whose solution is this. Okay, now whose solution is this is the differential equation. Okay. So, I hope that So you enjoyed this solution. So let us go for next problem. Dear students, welcome to this problem. So the problem is d square y by dx square is equal to dy by dx whole square. Then how to solve it, this problem? So very nice problem. So to solve these problems, you should have a fundamental theoretical knowledge. Okay, now first see here, d square y by dx square is equal to dy by dx whole square. What we can do is, so what is the definition of second order differential? So this can be written as d by dx of dy by dx is equal to, that is same as, right hand side I wrote same as. So this is the definition of this. So d by dx of dy by dx is nothing but d square y by dx square. Okay, very nice. Now what I am going to do is, this is a dy by dx. So if it is a, so in the so far we have taken some, if it is dy by dx is equal to 5, then dy is equal to 5 into dx. We are doing it or not? We are separating dy and dx separately. Here also this is a d of something dx, take dx to that side. So this is a d of dy by dx is equal to dy by dx whole square into dx separated. Okay, now right. Here dy by dx whole square is there, no? There are two dy by dx is there. One dy by dx take to right hand side. So this is a d of dy by dx, denominator dy by dx is equal to 1 dy by dx into dx. Okay, now right, very nice. Here dx you can cancel, then find the derivatives, take the derivatives on both sides. So dy by dx, denominator dy by dx is equal to 1 dy. Understand? Both sides I have taken integration. Okay, now so see here very nicely, dy by dx derivative is in the numerator. Dy by dx, the derivative is in the numerator. That means dy by dx derivative is what? D of dy by dx. So by a well known formula, we have the answer for this is ln of modulus of dy by dx is equal to y plus c. So that will be your final answer. That will be your final answer. Otherwise, so if you want to reduce that, this is equal to dy by dx is equal to, so this is equal to e power y plus c. E power y plus c. Again you can do this separately like that. So this is equal to dy by dx is equal to e power y into e power c, some constant k you can take. E power y into e power c you will get, e power c you can take constant, and separate the variables and separable. Okay, so this is equal to integral e power minus y dy k into integral 1 dx. So if you take e power y to left hand side, 1 by e power y, again it will become e power minus y dy. So integration will become, so this is equal to e power minus y, of course minus, this is a kx plus some constant, some you can take some L or anything. So this is your final answer. Minus e power minus y is equal to some constant kx plus again you will get another constant of integration. A very nice problem this is. So I hope that you understand this solution. Let us go for next problem. Welcome to the last and final problem. So this is other than this variable and separable method. So just for relaxation I am telling. So here y is equal to one solution. What is the order of the differential equation whose general solution is? This is a general solution. Why? Because here whole power c is there. So what is the order of the differential equation whose general solution is y is equal to c1 cos 2x plus c2 sin square x plus c3 cos cube x. So it is not cos cube, so this is cos square x plus c4 e power 2x plus c5 e power 2x plus 3. So generally students will think that they will start counting the number of constants. This is c1, c2, c3, c4, c5. Therefore the order of the differential equation is 5. That means we have to differentiate these 5 times, so that the constant C1, C2, C3, C4, C5 will be reduced. No, it is not like that. So, I already told that. So, we have to count the effective constants. But that is why before that we have to simplify this. So, for that what I will do, y is equal to, so first we will simplify this. So, this C1, write down cos 2x as it is, write down C2 sin square x. Sin square x can be written as 1 minus cos 2x by 2. Understand? C3 into cos square x can be written as 1 plus cos 2x by 2 plus C4 into e power 2x plus C5 into e power 2x plus C, no, C5 into e power 2x into e power c. Right. Now, therefore, see here y is equal to, here cos 2x is there, cos 2x is there, cos 2x is there. Take cos 2x common outside. So, what remains here? Here C1, this is minus 1 by 2, of course C2 is there, minus C2 by 2, C2 by 2. Here cos 3x 1 by 2 is there, of course C3 is also there, plus C3 by 2, this is cos 2x. Understand? Right. Again, any more constants are there? Yes. Here C1 1 by 2 is there, no? C1 by 2 is there, C1 by 2. Here C3 by 2 is there. Okay. Coming to there, e power 2x, can I take common outside? If I take e power 2x common, so here it is C power 4, this is C5 into e power c into e power 2x. So, like that, this is a cos 2x, this is constant e power 2x. Therefore, y is equal to this, all are constants, C1 is a constant, C2 is a constant, C3 is a constant. Therefore, their algebraic sum is also a constant. So, lambda cos 2x, lambda 1 we call it as, so this total we call it as lambda 2. So, this total we call it as lambda 3 e power 2x, lambda 3 e power 2x. Understand this? So, here what are the effective constants? Lambda 1, lambda 2, lambda 3. Therefore, the order of this differential equation is 3, not 5. Understand this? So, like that, first of all, given an equation, you have to reduce it into in a simplest form if possible. If possible, if it is not possible, we cannot do you cannot do anything. But this is here, it is very possible to do that, so that we can get here only effective constants are 3. Therefore, if you differentiate this function 3 times, this lambda 1, lambda 2, lambda 3 will be reduced. Okay. I hope that you understand this concept. Okay. And tomorrow's class, I will explain some more methods to solve the differential equation. Okay. Until then, all the best.